talk still from EBI, and she's going to be talking about what happens when you search for more via APIs.
Thank you for coming to this talk, and then thank you for the opportunity given to me to be here. My name is Youngmi Park. I'm working for EBI as a software engineer, and today I'm going to talk about EBI Search API. Before starting the presentation, I would like to thank my team, a production team in EBI, and there's a latest publication about EBI Search and EBI sequence analysis tools, so you can find more information about those services from the publication. The presentation will start with the brief introduction about EBI Search and what kind of data we are indexing so you can perform searching against, and then I will talk about EBI Search API. EBI Search is a full-text search engine to allow users to access the data available in EBI. So every morning we check all data sets we index, and we index updated data sets and then deploy new indices. So our users always can get up-to-date search results from us. And using the network of cross-references, users can easily navigate across multiple resources. And we provide search functionality and other useful features through the RESTful interface, which can be used to integrate those features into other projects, web application or workflows. Yeah. And here you can see some statistics about EBI Search. So now we index more than 2 billion biological entries available across over 110 data sets. And the last year, we processed more than 550 million requests coming from over 311,000 unique hosts all over the world. And this figure shows what kinds of data we are indexing now. So as you see, we index nucleotide sequences, protein sequences, and protein families, protein expression data, gene expression, macromolecular structure, small molecular reactions, pathways, literatures, samples, and ontologies, and so on. And we are actively working to add more new resources to EBI Search. Now I'm going to move to EBI Search API. This table shows what kind of features we are providing through the RESTful web services. So obviously search, so you can perform search against a single resource or against multiple resources. And so you can get a list of entries sorted by relevance or other sorting criteria. Also you can get facets which can be used later to filter a result. We provide cross-reference search, which is to find cross-reference information between resources or entries. Autocomplete is one of the common features available in modern search engines. And top terms API is to return popular terms from a specific field. This API can be useful to see some data characteristics. And the searching applied on sequence search result. This is a very new and very experimental API, and I'm going to talk about this later. And more like this API is to find similar entries to a particular entry. Using the raw data retrieval API, you can get raw data of an entry we indexed. So I will move to search first. And this is a search result example on our web interface. As you see, in the middle section, there's a list of entries in this example, these entries are ordered by relevance. On the left side, you can see a process which users can use later to narrow down result. And the more or less same information can be obtained through the RESTful API. And this is an example of such result coming from API. So as you see, there's a list of entries and process. So you can simply implement simple search engine page using this API. We provide cross-reference searching APIs, so which helps to find the linkage information between resources or entries. We provide 3 different APIs for this feature. The first API is to find the resources referenced by a specific resource. On the right side, there is a response example of this API in XML format, and the example shows a list of resources referenced by Unipro data. The second API is to find resources referenced by a particular entry. So on the right side, the example shows a list of resources referenced by a specific Unipro entry. This API can be used to show or see the overview of cross-references of a particular entry. And last API is to find the entries referenced by a specific entry. So the example shows a list of publications referenced by a single Unipro entry. What makes our cross-reference searching is a bit unique is that it works in bi-directional way. So for example, some data like Unipro data have a cross-reference information in the data file we index. So it's quite straightforward to give users a list of cross-references of Unipro entry because we have the data. But some data like publication data, they don't have cross-reference information. But even though there's no explicit cross-reference information in the publication data, we still can give users a list of entries referenced by publication because it works in bi-directional way. And I will move to the more like this API. This API is to find similar entries to a particular entry, and how it works is quite simple. So first we select a set of repetitive terms from the given entry, and then we build a query using those terms and then execute it and give back to user the result. And there is an example publication, and this is the abstract of the publication. And then the bold terms are the terms selected for the next query. And then we build a Boolean query using those terms. And then this is the outcome of the query. Normally, the first entry is the same as the given entry, so the second entry can be thought as a most similar entry. And then this is the abstract of the second entry. And we provide a number of parameters to tune the result by changing the rules how to pick up terms from the given entry. And this is the last API I would like to talk to today, and searching applied on sequence search result. And as I mentioned, this is very new and very experimental API. And then this is actually the outcome of collaboration work we've done with the RNA Central in EBI. So RNA Central team provides a sequence similarity searching tool on their website. So users can input sequence and then trigger the sequence similarity search, and the RNA Central run the tool and then give back the result on the web interface. What they wanted to add to this feature is that they wanted to give a way to filter result, like applying process onto the normal text search result. So we worked together and implemented, and I will explain how it works. So there's a user, as user input a snippet of a sequence and trigger the sequence similarity search, and then RNA Central run the tool, and then produce a list of similar sequences, similar entries. And the RNA Central call EBI Search API. And EBI Search already indexed the latest metadata of all RNA Central entries. So using the RNA Central index and then the outcome of the sequence similarity searching tool, we can give back to RNA Central a list of entry and the relevant process. And RNA Central display this result on the web interface for user. So in the middle section, there is a list of similar sequences which are coming from sequence similarity searching tool. On the left side, there are processes which are coming from EBI Search API. If a user apply a facet, RNA Central will call again EBI Search API with updated parameter, and the EBI Search will give back to RNA Central refined result, and the RNA Central update web interface. This API is not only for RNA Central and our team, web production team. As Fabio mentioned, we are providing EBI tools, sequence analysis tools. We are working to integrate this API to the tool, so we will hopefully provide a similar functionality to our users. And the RNA Central team is going to give a talk just after this talk, so you can find more information about this new sequence similarity searching tool from their presentation. Yes, I think I have done almost what I planned today. Here, you can find some useful links. The first one is where you can find more information about EBI Search. The second is the documentation about EBI Search API. So you can find all information about EBI Search API, what kind of API available, and the parameters per API. Also, you can try your test code from there and also see the result on the web interface. And we also provide a number of sample clients written in Java, Python, Perl, so you can download, and then you can try to start interacting with our API through them. And if you have any questions or suggestions later, you can contact us through the user support form. And thank you.
Or any documentation describing the technology stack behind, because I'm interested how to combine so many data and make the search feasible.
Do you mean what kind? We don't use Solr or Elasticsearch for this, but we build the Java application using the Lucene Apache library, Apache Lucene library. The part of the reason is the project started more than 10 years ago, and at the time there was no Solr Elasticsearch, so we had to write down the software from scratch. That is the reason. And if you want to know more about infrastructure, I mean the searching or indexing part, maybe we can have a chat after the presentation. Yeah.
Thank you very much.
No problem.
Actually, I have a question related to the use of the RESTful API. Is there any limits in using the your services? I mean, if I write a tool using the RESTful API, how many queries I can send to your servers, let's say per minute, or something like that?
There's no hard limit because normally the query performance depends on the query, so we can't say you shouldn't send how many. So there's no hard limit, but definitely if you, bombing the service, definitely we will get in trouble, but there's no hard limit,